everyone, welcome to another stream. How's it going? So, I'll do a quick recap and then we'll get into what we're doing today. So over the past so many streams, we've been working on a build system in C. You know, we used to have a version that was written in C, but we're just rewriting it properly because I'm trying to get going on working on a game prototype, but the current build system is going to be in the way of that. So I'm just getting this out of the way such that we'll be able to hot code reload and hot reload assets as well. So we change an asset file, it shall present to the game, hey, this has changed. So the basic idea is that I have a system where you run this build script and it in the background it just watches for files and sees what needs changing. This is the sort of unique thing about this build system. So it's already running outside of any editor, and anytime you make a change to anything, it will rebuild those assets, right? And then present to the game, hey, this has changed, and then the game just literally reads from a message queue or something and then reloads those assets, right? Now, the current version of the system was quite manual. It was like, you know, I defined a bunch of commands in some kind of order, and you could put a barrier down. So this meant that it was nice because stuff is defined in code, but it's quite manual here where I'm manually defining every single file, right? It's not really the best. And yeah, it could do with some improvements. So effectively what we've got now is we're doing a DAG. So it's a directed acyclic graph, I think you call it. So effectively we just map out all the inputs and outputs of every single command which we're going to run, and we join them up in a graph, and then we're going to today be writing the code, I think, where it executes that DAG, where it traverses to the top of the tree with no dependers, right? When a command depends on nothing, those ones will run first, and they will basically trigger the rest of the tree to be executed as and when they become when the dependers become 0, right? So yeah, this is the new system that we're working on basically. So we index the file system to begin with, right? Get a list of files so we can just quickly search that list. We reset the DAG, we build the DAG. So at the moment I'm just looking at all the GLSL files. So we added a way to basically do these you know, you're going through every single directory and then going for every single file in that directory. So we can pick up all of the shader files in a single directory now, which is great. And effectively we have the way it's going to work is you'll build the DAG tree. If we haven't come across any shaders or anything that needs building that is missing a dependencies file, so we can't work out all of its dependencies, then we will, yeah, if we come across something that needs to work out its dependencies, basically, we won't actually build, and we'll execute. We'll execute all those commands, wait for it to happen, and then it should continue back around. Actually, I did forget to do that code. Let's write that in quick. But it wasn't allowed to build. Something like that. Then yeah, but so it finds all the dependencies. So run like glsl -md or whatever and produce these dependencies files, which is quite nice. And so it will only do this if they do not exist. So when you've never built the code base before or you've deleted your build folder, basically. It's these guys. You've seen these before in the past, I'm sure. So with this, the compiler will tell us all of the dependencies this file has, and we can just depend on those in the graph and work out which compilations need to happen first. And also we can then check to see what timestamps have changed. So when we can know, like, oh, because you've changed the header file, we need to rebuild that whole shader, basically. So that's quite handy. So effectively, we have a yes, only when we've found all of the dependencies and we run this from the beginning again, will we execute the DAG and run a full build. Then we have this system called an executor, and that basically runs any command in the background. So you would call executor, I forgot what you'll call now, there's a few commands. Yeah, Q command, right? You'll queue either command or a find dependencies pass, and that'll find the dependencies. And that just happens that launches a process, and it is managed by a executor background thread. So there's this whole executor subsystem right here that just deals with tasks which are running, and it has a task queue of tasks to run. And when we boot it up, we say, right, how many threads have you got to run this, to run in the background, basically. So everything that needs to be launched runs through this executor system. So this is the main thread thing, where it basically just, you can end up waiting for jobs and then sleeping the whole system. But then after it's found some jobs, it's going to queue them up, basically. So it's going to launch them and then put them on the running handles. There's probably, if you have 8 threads, there's 8 of those. And then we'll wait for any of them to be finished. And then when they're finished, we basically take them out of the list. And once they complete, we can then do some code to handle those. So if a DAG completes, so say if you finished a command, which is maybe a code generator, right? The code generator will generate some C files, and then that will be like, right, so now these C files have been generated. The nodes which depend on those to be generated can now start compiling. So this is where the DAG will be progressed here, basically, and add more jobs to be executed. So we have this executor system. Off stream, I worked on this. We need a file system watcher, basically, something that watches a directory and figures out what has changed. So I made this very recently off stream. So it's just a system to, you say, hey, watch this whole directory here. So because the build system runs in the background and it just waits for you to change files, we need one of these systems. So it's another thread which runs in the background. So it's using the IO completion port on Windows. Obviously, when we pull this back to Linux and other stuff, it should work out fine. So effectively, you watch a directory, it creates the directory handle, and then it registers it using the completion port. There's a bit of a problem where basically when you call read directory changes W, from that point onwards, you will be reading events in the background to... Hang on a minute, I just completely messed that one up. Come on. To this events buffer here, right? Because you give it the pointer to it. So only when you call that function do you do it. So yeah, so when in the thread which basically processes all those file system watches, when you call this sort of get queued completion status, as soon as this function returns, that directory is no longer being watched. So if a file system change happens, after this, you're going to miss events. So there's a trick that you can do, and it works out for us, but it might not work out for everything. So yeah, this function gets called here, watch directory issue. So it's just this read changes W, right? Then, so the trick is basically you do it twice, right? So you make two different queues for the same directory that you're watching. And when one of them returns, the other one is there to collect the events, and you don't get duplicate events either, because the IO completion port will use the one which was registered first, thankfully enough. So that's the trick we're using to avoid missing events. So yeah, it's just like the executor where we have a thread that's made for it, and this will basically wake up as and when file system changes happen. It will copy the events to a local buffer, and then it will reissue it. And then I don't know if we need the copy, to be honest. Yeah, and then we just basically iterate through that local events buffer. Did I mess that up already? I think I might have done. No, we haven't. Cool. And then we basically just queue it up onto a global queue. And so from there, we can pick it up off a queue. So there's this sort of API where we can say, like, from the main thread, we can be like, right, wait on any events from our file system. So once we've done building absolutely everything, the whole build system can go to sleep, right? Wait for any changes in the file system, and then later on we can basically just iterate over those, and then change some of the timestamps, I think, and maybe register any new files into the index file system list. This is stuff we've still got to write. And then, yeah, we can go back around again, rebuild the DAG, see what needs to be built, taking into account the timestamps, and then execute the DAG again, right? So, yeah, that's basically a quick recap of the system and what things I've done off stream. So today, we're working on, the timestamp system is already done. It's just not wired into the new sort of rewrite thing that we're doing. So we just got a timestamps file sitting in the build directory. What was there? It's just basically a list of paths and when was the last time they changed. Yeah, when was the last time they were built against successfully, kind of. And we need to discover new files in the file system watcher thing and add those to the file index. We need to write the DAG execute function, right? And we need to write more build commands such as compiling C code with Clang, copying assets, and the CodeGen stuff. So we'll be doing some of this stuff today and some of the other things which we just went over. If you have any questions, feel free to ask away. We'll start with a quick prayer and then we'll go. Father in heaven, thank you for this day. We bless your holy name. Thank you for all the food we have on our table. The time we live in is a very blessed time to be alive. Things are quite easy, and you have access to lots of information, warm showers and even hospitals with lots of knowledge there to keep people alive. And there's illnesses and things. So we just thank you, Lord, for this time to be alive. Thank you for our families and our friends, and the peace that we have in the places that we live. I just pray for anyone who's going for any hard time right now in their life. Swings by today, I pray, Lord, you amend that and fix that struggle, Lord, and please let your name be glorified in this matter. Also pray for this stream today that we, achieve what we set out to achieve, and all the viewers come by and get something that they can take away and from it. And also pray that pray, Lord, that each one of my viewers as well will come to know that you love them, Lord God, and that the gospel message that Jesus Christ is the way, the truth, the life, the only way to the Father and heaven is through you, Lord Jesus. But I thank you, Lord, for everything you've done, and I bless your holy name. In Jesus' name we pray. Amen. Right. Welcome, everyone. How are you doing? Man, it's a hot day today. This room is already scorching. So, where's the start? Good question. So, I think let's start with this sort of, should we do the timestamp system maybe? Yeah, this is why the timestamp system in, because, or is there someone else? Or would it be fun to actually launch the commands and stuff? Well, the timestamp system is already there, so let's go to timestamps, right? So there's this file timestamps parse, and it just is a build a timestamps file, right? That either exists or doesn't. There's a save for when things successfully complete, and there's a way to find with a path hash. Now, I actually have a hash table now, so maybe this whole thing is a bit dumb, right? We actually have a proper hash table, meaning we don't have to scan over everything, right? That's quite crazy, right? If you have like hundreds of files, you're scanning over that hundreds of times, 100 times 100, right? And if the more you get, the bigger these numbers get. So a hash table will be better. So yeah, I think let's wire it in. Okay, let's sort out that problem first, because I think we do this find a fair amount. Well, this was the old watcher stuff, right? Yes, let's sort this one out. So, all right. So I think we'll make a structure and we'll call it like a timestamp. I'm trying to make it a little bit more proper as I go, because we'll just jam together some of this stuff. So we'll call it like a timestamp. There's a file timestamp. Has to be a file timestamp. DB maybe, right? It's a database, if you will. I don't know. Let's just do that. Sorted. So we'll stick it above the executor, I guess. I don't know. We still have some of the old code around here. So this is old code here. So the file is a little bit bigger than it is supposed to be, because I'm just copying and pasting stuff and redoing it with this new design. And we'll delete the code as when we get there. So this is going to be the so do we ever scan over all the timestamps, like when we serialize, right? I think for serialization. By serialization, I just mean like dumping out to a text file, right? It's not anything too yeah. So I think that's the only real case, because the find is going to be, yes, I think we'll just do both, right? We want an array, we want, so I guess we'll just do hash table. We could do maybe an index or a pointer is probably fine. So do you want to call this like a timestamp? Is it more than just timestamps? Maybe it's file metadata, I don't know, but anyway, timestamp. Right, let's just roll with it. Timestamp from path map. That's what we like. So we'll just call it timestamps. So path hashes goes now, which is super great. And I guess we can just get rid of this here. Cool. So those functions Oh, it exists right here. Okay, so we just take all of this and we move it. Oh, okay. Right, let me get the other one. There we go. Cool. So parse, save, update. Yeah, update is going to probably get the latest. Yeah, something like that. Yeah, I think these days we just want to use a string. Because that's what the hash table takes as a string, which is, it's got a count in there, size. Remove. This is an interesting one. I don't think I have a remove on the hash table at the moment. I guess we could add a remove, maybe. Yeah, maybe we don't really care about remove because it was causing issues, I think, because sometimes you'll delete files and then, programs might quickly delete and then reinitialize them. Recreate them. So I think maybe, yeah, I think we're going to remove because it's probably not a sensible thing to do. Like you're just going to literally fill up a file with. You could just delete the build. You probably will delete the build directory by then, right? And I'll clear it up. So I think we're okay to get rid of remove for now. Has changed. And then timestamps clear has changed, whatever that does. Let's have a look. Okay, I think what we'll do then is maybe we'll call it a file DB. And then file. Yeah, we'll call it a file database, I think, or file. You call it metadata. Something like that. Yeah, I think we'll just call it file database. Let's just do that. So rather than file timestamp, we'll call it just file metadata. Bit of a generic term, but it does make sense, right? What does it? Yeah, it does. Right, so file database. File metadata update or something like that. So it has changed. I'm not sure what that does again. Right, it would. Oh, right, yeah, okay, of course. See if it's ready. Yeah, I guess we can just do file has changed. So update would. Find the file. Get the latest timestamp and then just update it basically. Yes, so we probably want to. I wonder how often it did that update. Yeah, file metadata update, I guess we'll call it. Well, clear has changed. That's interesting. Well, I think we got rid of that in the end because it used to be a Boolean. But now we actually have 2 timestamp things. Okay, this is good. So I want to stick this in the build thing here. We'll do this and something like that, okay? Website database has changed, isn't it? You know, we say file. File needs build or something like that, right? There we go, that's better. So, I like this change, it's very good. So, it's the file database. So, you have the file DB parse. And we probably want an initialize as well, which we'll get to. Right, so file DB update with, so we can get the file DB here. Call it D, I guess. Okay, so it's trying to... How often did the update with get called? Right, a few places. So, yeah, we might need a function to... Yeah, it uses indices because it might look in for the hash. We don't have a parallel array for the hash anymore, so I think we will just type or pass in the metadata, right? Okay, so f. Right, so file timestamp has changed. Cool. Nice. Next, this parses the file. It's just literally a new line for every file that we know about in a text file, and it's separated by, I think, a pipe or something like that. And it's just got the, you know, the timestamp values in there. All it does. So this will clear everything. So and we need to do a clear on the hash table. Okay. So it's just appending. No hashes anymore. We just compute those on the fly when we search the hash table. And yeah, that sets everything up just fine. Build directory. What is this? Oh, the system needs to be destroyed. Yeah, I want to comment that one out, please. Let's wrap that in F0 so we remember to delete that. It's just the old watch directory stuff. We've got a new one now. Right, so where was we before? So, right, back up here. So now this should complain. So this was saying watch directory deduplicate. So that would take a path it would loop back and find, yeah, do a string length and then normalize. Right. Yeah, I think we need one of these. I think we need this code kind of thing. Yeah, that was search all over an array as well. So in our current directory watcher, which is the new one that I wrote off stream, we've got this sort of directory watcher watch directory. So this expects you to have already sort of sliced up yeah, so I think we might want to ensure we're not using it yet. So maybe I think we want a function in the strings just to be like, yeah, it's in the string code. I think we want a function which basically, I don't know, I've already got it. It's os path. Sorry, I think it's just path something else around here in it. Oh, okay, I just put in the, oh, here we go. These are the guys. So pop extension, pop front and pop back. Yeah. So we want to do this, but then like, so I think I want to make another function, right? So we'll call it like, yeah, so you pop the back, and then we probably want actually just a dupe. And the reason why I want to do a duplicate is because we want to null terminate it. So this would be something like a, an alloc array string size plus, we don't, yeah, +1. This is the destination. We'll memcopy dst string data string size, and then we'll plop on the end dst string.size null term. And we won't include the null term in the size, right? Because it's a bit annoying if you include the null term in a string, right? But it's null terminated, so we can use it for operating system paths and stuff, right? When we give it to the operating system. So that's what this is for. So yeah, we can quite easily call that function now. So go back into that file system, to the file database. When we parse that timestamps file, I should probably call it now build.filedb, right? That'd be better. So it's just, line by line, file, timestamp, right? So the last success and the latest timestamp that we have, yes. So this would actually be a directory watcher, watch directory, whatever this path is, right? This should be a string now. Interesting. What did it do here? Alloc array. Where's the path at? Oh, it's directly from the code, yeah, this file in it. So yeah, you know, we could point to it. Oh, why would take? Oh, because we're on a null terminate, of course. Yes. So I think we'll just do that string duplicate thing that we literally just made. String duplicate null term, right? So you'll do path. So string path size. Lovely. So this one here is going to do we're going to do that string dupe again. Luckily the allocations are quick, so it's not that bad. But before then, we'll do a path pop back. Right, so we'll pop the file name off there. We'll pop the extension, obviously, and the file name all together, so it gets the directory. Right, and then we watch the directory. Now, yeah, I think that'll be fine. Yeah, so does it... Right, so we reverse find the /. Yeah, and that becomes the new count, the new end index. Okay, that's fine. I'm happy with that. Okay, so keep carrying on. So this is the new... Right, that's a good change. This is the new file database. Instead, it's now called file database parse. Nice. But this file database save. So again, we'll take a file DB in here, please. DB, let's call it D. gbuild.file database. I think that's what we did. Build.file database. Nice. Now, be careful with some of this stuff. Cool. What else is going on here? So the save was, it goes all over the files array. I do have my for range now, so that might be a bit nicer. More concise. There we go. And so we get a file metadata. Yeah, so we just print out the file path. I can just do a .data there, that'll work. And then, because it's null terminated, which is great. And then, what else is here? Oh, F is for file. Okay, so we change that to, I guess, M. Right. So now find, this is the one which has changed. So we got a hash table in there now. So we're not doing this like ridiculously silly thing, right? Because the more file timestamps we have, we're going to basically be searching over that for every single file. So a hash table will be better because a hash table basically puts empty spaces in between everything such that it jumps, searches a few things, finds the answer, rather than searching over possibly 1,000 entries every single time it wants to try and find a file. And obviously it only goes so far depending where the file is, but yeah. Hash tables are way better for this. So I think, oh, hang on. Yeah, so find was only used, right. Yeah, we need to make that more of a public thing. So I don't think we need an index anymore. So we used to use an index because we used to have a parallel array. Don't have parallel arrays anymore. So this will be the thing we do. So simply return hash table find. So it's just a void pointer. It returns that the value is always a void pointer in this hash table, and the key is always a string. So it's just, it works perfectly fine for this project that we're doing, right? So no biggie there. You know, I like putting the local variable. Right, this thing, the key, path, and voila. Obviously it needs to be a normalized path and all that if it's going to work. Right, so you probably want to move that comment to the header file. So path must be normalized with this, right? That's what we expect. We can't be doing it automatically because if not, it just makes the code very slow. Right, we need to avoid doing slow stuff. The metadata update. Right, so taking a path. So do a find. Yeah, so that needs build, so that has changed. So I think we'll make that a separate. Yeah, I think we'll offer up the find. Where is it? Yeah, so I think we'll make it such that you have to use the find API to get the metadata and then pass the metadata in to know whether or not we need to do a build or not. That'd be better. Okay. Yes, we do the find, we've got it. So here it is here, the file. We do want to get the database here as a little local. Lovely. So if we've not found, sorry, if we have found, so we have something and file DB file needs build, so that means it has changed. So it's already kind of updated with the latest timestamp. We might as well just do a new build. I think, is that what we're saying? Yeah, we've probably updated it and not built yet. So let's just build first. Because it's probably not changed since then. So that'll be F, lovely. So path.data. Yep. So there's a stat, get the latest stats. So if we found it, then we just update with thing. Yeah, we'll see how it goes when we write the watcher code. So file database metadata up. Oh no, update. Is there an update with? Hang on a minute. Where are you? Here we go. We'll write the word metadata in there. Keep it consistent, you know? Right, so pass in the file. There's the timestamp there. Right, so then we failed, so we're going to insert a timestamp. So this one is basically this code here. So I'm just going to copy that. So I don't think it needs to be added to the directory watcher, but I've copied that code just in case. I think it does actually. Right, so here's the old code. So it's the same code, I think, just a bit different. So success modified time is 0. So that means like a successful build, right? That's the latest timestamp. So that means it's going to try and build everything that depends on this file. So what else is different? Yeah, this is fine. We can just delete it. And yeah, it's the same. Cool. So I guess we could have made like an insert function or something like that. That would be technically be better. It's just two places where it does it. But yeah, that'd be fine, I think. Well, let's just do it, right? I don't typically do this. My usual rule is like 3 or more, or maybe sometimes 4. But you know, I'm manually inserting to arrays, and the code's getting a little bit chunky. So I'm thinking it's probably validates a function. So we can say like metadata add, metadata push. So it's something that's for sure. Yeah, and the code is also is basically the same, just an extra parameter. So we probably want a success and a latest modified time. That's what we want. So these two things here, right? So success. What one's first? Okay, success then latest. All right. Nice. Looking good. So this will get called from. Oh, I went past it, didn't I? Parse here. We need to pass in a string as well. So it's time s, time s. Yeah, what was the oh, the path is already passed in autumn dedupe. Right. I see now. Needs a string path, of course. Did it before I hang on a minute. Yeah, just use to copy the pointer over basically. Okay. All good. Right, where was we? Right, so this will go here. So it'd be path. Call it string, I think. Okay. Nice. So the one down at the bottom, so that was the parse file, but the metadata update. We'll just do this. And voila. So it wanted a 0 and then a time s. Oh, where's time s coming from? It's stat.st. St what? stm time. That's all we want. Oh, it tells you there. Whoops. Right, so 0 for this one, and stm time. Cool. That's very nice. Just update with. Right, so this changed one is like it's like a needs build. It's this guy here, yeah. This takes in now a file metadata. Wow, this used to be very bad. Yeah, now it's just a little one-liner. Cool. There's a commit. Right, so the commit, that's an interesting one. So this one's like, hey, we've finished a build. Now go over and basically say, right, these ones were successful, right? So yeah, so the thing is, right, I never handled this properly in the previous system. So this is part of the reason why I'm doing this rewrite. So you can have a file, right, a C file or a header file, whatever it is, used in multiple different commands. One command finishes successfully, the other fails, right? So in that case, you probably don't want to mark that file, that header, as having a successful modified time, as one that we've built with successfully. So I think we need to build some kind of thing where we need to handle that properly. So commit is the wrong thing. We need to figure out how we do that. So I guess we'll save that problem for later. I don't know what we'll do yet. So, well, maybe we can think about it. So like if the DAG fails, right, what, if we execute and we find a failure, are we just gonna stop execution? Yeah, I think these are questions to ask, right? And how does that work with timestamps? Yeah, we'll save it later. Because we'll literally be trying to build it and think about it very soon. So here's the file system database basically, amended now. The initialize needs to be sorted out so it gets built in it. So rather than initializing it here, we'll call file db init. We'll take these two, we'll delete that, take that. So it's just simply something like this. Then hash table init the map, the capacity. There you go. Cool. So now we need to wire it up. So right, here's the new loop. So when you boot the system up, you want to parse the file, right? So here's the parse. So you want to say file db parse. So now it's loaded. What other stuff you have? You have save. Do you want to save when there's been a successful build, basically? So yeah, we need to figure out this. No, we'll come back to this when we've got the DAG done. Yeah. Because we would have thought about it more. Like, what happens when we get errors and stuff? Right. So where are we now? So we basically have this DAG. I've got this thing here. So we output it as a graph is viz.dots file, so it can help us view a graph. So, there's not really a good desktop application apparently, and of course everything gets built into Visual Studio. But yeah, it doesn't really, we have so many dependencies, same dependencies across these guys. I'll just get these big thick lines because there's a bunch of like header files which are shared or something like that, like these. Anyway, but you get the idea, right? There's some inputs, there's commands, and then there's an output typically. So with this, we can find all of the commands which have which it depends on. So all the commands which files it depends on, which don't depend on any other commands to produce them, and they're ready to go, right? We want to find all of those and then go through that whole tree, right? So you probably throw that on the executor or something like that. and the execute will like churn for it. But you don't wanna, you only want to put stuff on which need building. So say we're talking about, like, you might check a command, like say if you got like a code generation command, it generates a C file. Well, you haven't changed any of its inputs, so the code gen doesn't need to run. So then that that shouldn't be chucked on the executor to run, right? Instead, we should walk the tree and be like, right, mark some nodes and then execute that the next node, which is available basically. So yeah, we should do that instead of chucking on the executor. So I think let's write the DAG execute code. Is there anything else to do? So timestamp system. There is the watcher. Right. I think let's do the DAG execute. Yeah, so it'd just be a recursive function call, basically. So I think, no, recursive functions kind of suck as well. I think it's better if we manage the stack on an array, maybe, but maybe not. Yeah, so let's get a, yes, you could have like a, so you got a node, another node. So these are maybe a couple of files, right? File 1, file 2. There's like a command here, yeah? Command 1. So then I guess command 0 generates file 1. Yeah, something like that. So then you might have this will produce a file 3, which is the executable. Something like that, okay? You'll start somewhere. Maybe you'll go over. Yeah, we're going to find an algorithm. So we don't really know what is the most bottom, and we don't really know what is the most one of the most top. So we'll probably just iterate over all of the nodes and find the nodes which have no dependers. Basically, right? That's the objective, right? Find the nodes which have no dependers. Those ones you can then check to see if we want to execute them. And then, like, or if they're ready, you would basically then go down to the child and then say, you know, you're ready. So then if both of these are now ready, it can now actually say, you know, this is a command that we want to execute. Right, and then you basically skip running this command here. Yes, I think that's the logic you want. So we need in the DAG, we need some kind of array or something like this, which will store some kind of array which will store these are the nodes that I want to run. Right, so you call it probably a DAG. Now, when you've found this list of things to execute, they will get run on the executor. The executor will run the processes, and then it will kind of just wait for them in the background to be done. When they're done, it will then move the graph. It will then do the same sort of thing where it will mark bits in the graph, right? So when there's zero dependencies ready to be waited on, it will then, instead queuing them up to go here in this array, it will instead go directly on the executor, right? So I think what we're doing really is this thing here, this sort of DAG. I don't really think it needs to be a structure, thankfully enough. I think we can just do a little local array. So we can just do one of these DAG allocations. So these have the lifetime of a DAG. We blow away a DAG. You know, the graph gets blown away every single time we try and do a new set of builds. Rather than trying to maintain it, we just throw it away and rebuild it because it should be fine. So if we just make an array, which will be the size of how many nodes that we have, because that's, yes, we'll say like, you know, DAG. We're just looking for commands to run, so I think it's just something like that. So, right, D, there we go. So DAG command node. So nodes to run or something like that. Commands to run. Now we search the full array. D commands command nodes. So we get the DAG command node. I guess we can just call it C. Now we're just trying to find the ones which don't have any dependencies. So just be C, the input list head. So we just want to traverse that, right? So here's some code I found that I did earlier. And we literally just, so it's got a file node dependency, right? So this, there's a creation command node, right? So what command creates this file? Right, if nothing creates it, it means it's already created, right? And therefore we it's like a it's like a source code asset kind of thing, source asset, right? So this one, if this is null, then we say success equals true. I guess we're going to and, you know what, it's probably success and equal, right? All of them have to be equal to null for all of the input dependencies, right? If one of them is generated, it's not a command that can be ran out of the blue. So the next thing is to say, well, if we succeed, then simply append on the command node, like so. So yeah, I haven't really validated the DAG as well, so I'm expecting there to be, you know, when I need to debug this thing, I'll probably write the debug code. But for now, we'll just skip over it. Like, you know, verifying the DAG is correct, stuff like this. Like, you might not have any ways to successfully trigger a build on, sorry, run one of the commands for some reason. There could be some invalid way it's been configured, but I hope not. Right, so this essentially just finds find all source files, right? So files that don't need generating at all. So now we want to basically look over all of those ones that don't need generating at all and see if they need to be built. So now we go over all the input dependencies again. And we say, so now there'll be a dep. Hey there, a hobby. Welcome, sir. How you doing? How's things? So this node has a path, right? Now we have that timestamp system that we was actually looking at before here. So there's like this timestamp. I guess we want to do like a needs build, right? So yeah, this is kind of questionable. What does it find? Doing well, awesome. Yeah, not doing bad, thank you. You know, it's quite warm today, so I was around my family's today, having a barbecue after church, and yeah, it was like quite warm. I drank like 2 Pepsi Maxes, had an ice cream, and yes, warm in this room as well. But yeah, not doing bad. Not doing bad. Just trying to prepare this project to start working on a game, really. Just getting all the bits together so things won't get in the way when I'm trying to prototype a game, which is cool. So yeah. Gonna be working on this build system, sorting it out, and then making sure hot code reload works flawlessly, and hot reloading assets as well. Make sure that works flawlessly. And when those are done, I think it's ready to start making the game prototype. But I also need to reveal it as well. So I'm not sure how I want to do that. Like, if I want to not care about working on it on stream and then do a video about the game prototype and put it up on YouTube. I think I might go that route because I'm not finding the time to work on a little presentation or sort of write out the documentation on my PC. I've got a game prototype written on my phone in some notes. But yeah, and I want to like compile it together into a nice presentation. So I think I might prepare it on stream, it'd be cool. Interesting. Even though I don't understand any of this thing, but looks exhausting. Maybe it's not for you. Even though I don't understand any of these things, but it looks exhausting, maybe it's not for you. Not sure what you mean. It's quite warm. These things. You mean the coding? So you think coding is not for me? Yeah, coding is. I've been doing it for a long time. You know, I can do coding in my sleep. It doesn't take too much It's easy. Yeah, I do it for a living, you know. So it's a bit strange. So file metadata. There we go. So if we can find a file and then we do a need update. Success modified time, latest modified time. So if the file has been changed and it's not been successfully compiled yet, this is what we're looking for, right? So for all of the input dependencies for these commands that we need to run, if all of them don't need a build, then we need to take that node and then mark the fact. Yes, we need to store like in the command node. Hey, what's the number of dependencies that I thought it is a project for your own game app or something like that. Yeah. This is project is my own game. Yeah. It is hard work, but that's the point, right? Kind of. You want to achieve something that's worthwhile. But no, it feels like you're just projecting your sort of like mindset. You know, I work. I'm as a profession. I don't. I hate the word professional because people use it to seem like, oh, this person's a professional, but professional just means you get paid, right? You know, I get paid. I do programming. I work on game engine technology and stuff like this for a living. So I do this all day. Yeah. So I think we want to have like a number of dependencies, right? That we dependers waiting on dependers count, something like that, right? And we just decrement it. When that's 0, this node is ready to go. So maybe that's yes. When we're building these command nodes and all that, so I think we say like add input, right? So you say add input. So you got these input files, right? The commands. Yeah, so I think you just want to +1 on that, right? Yeah, that obviously initialize to 0. So I'm gonna do the execute then. So because these ones have no creation command node. Or do we want to mark a file node to say So we can go over all the file nodes and mark them as like, hey, this one is now built and ready. So when a file has been, so when a command is done, it will go to the dependencies, so the files which are output, and it'll say, right, this one's been built and done now, this one's been built and done. And then it kind of would spread to all of the commands that depend on that file. And then just decrement the dependers. Yeah, I think we don't need it at the file node level, but more at the command. Yeah, I think that's right. So, right. To go over all the commands. Hey, Double Truth. I'll be curious to see how this benchmarks against Ninja. Yes. Yeah, I don't know how Ninja works. I think it might be doing DAGs as well. I remember looking at source code a while back. But yeah, the Ninja has like a text file that it parses up and does it that way. I don't know how often they parse that, but the reason why I'm building this system is because I want to make it like watch the file system and then like go and instantly do the changes that way, right? And it's outside of any IDE and all this, right? Because you can know how crazy some of this stuff gets when you try and integrate your build system into different IDEs and that. And then also when the build's done, the build system is literally going to be like, hey, game, via some inter-process communication, it does it via a file or something. You know, these files have changed, hotcode reload them. So there's this, I think, right, you know, really improves, you know, the build system's already kind of running, right? So you don't really have that sort of time where you go, right, okay, I've typed my code. I know sometimes people press like F5, like save, launch, and run. But yeah, as soon as you save, basically, it's gonna, build system will pick it up, go build. So there's less stuff to like, you know, switch between terminal windows and all this, right, to do before you press run. So it has those kind of differences to Ninja as well. But yeah, it'd be interesting to see what it's like from like a cold boot, but I don't know if I'm worth investing the time. I might benchmark it though to see what stuff I can improve. Like I want to get rid of any system calls for like checking if a file exists. This one I'd probably do a little bit too much. Just avoid the system calls as much as possible. Do it that way. So, right, so we go over all the commands that we're gonna run. If none of the input files need a build, if none of the input files need a build, then yeah, I guess it's the same thing basically. It's this again, isn't it? But with this. Alright, here we go. Hey there, Ben Chillin. Welcome, sir. That sounds good. I basically do something a bit more crude and have a key bind which binds and hot reloads certain game code segments. Nice. Yours sounds like a permanent run-in process. Yeah. Yeah, so mine's gonna work for like assets as well, right? That's why I'm building it too, because it works for assets. That's the plan. So this wants to mark all of the there's an outputs list. Here we go. And the output is what? A bunch of files. And then those files have a bunch of dependencies, right? Dun dun dun. So yeah, dag command dep. Oh, linked lists. Command dep. Right, so I guess we'll call this a cdep, and we'll have an fdep as well. Right, so while cdep cdep equals cdep. Now, so these are the commands where we go, right, command dep yes, only one command can output one. Sorry, one output. An output. A file which is output by a command can only come from one command, right? There's no multiple. There's no two commands create the same file, right? We don't have that sort of system where you can sort of like in parallel have two processes write into the same file. It doesn't work like that. They'll have to be dependency chained. So because we have that, you know, we need that, we'll obviously change the build system, but for now, this is the way it works. So because it works that way, we can, where is it? This one here. Do this waiting on dependers count decrement. Logically, that makes sense. Some people say followers of the Abrahamic religions pray to the same God. Do you think it's true? So I think Jews and, well, I'm not sure about modern day Jews, but maybe kind of they do. Yeah, they do, but they're lost. I think that would be true. Because the thing is about Jewish people is they have the Torah, right, and the Tanakh, I think it is, where that's the Hebrew Bible, right, the Old Testament. So they have the origins of the true God, right? But they've gone and done more stuff on top of that, where you've got like Ben David, which is like supposedly the messianic figure, and there's another guy as well. I think they've got like two messianic figures, which is interesting when you look at Revelation. There's two physical. There's the Antichrist and the false prophet, right? But yeah. So Jewish people, I'd say yes, but I wouldn't say Islam, because Islam is the the Quran. It differs from the Christianity Old Testament and obviously the Jewish one, right? The Jewish Old Testament and the Christianity Old Testament are the same, right? They come from the same sources, whereas the Quran is like, you know, so for instance, in the Quran, the reason why Muslims don't eat pork is not because Jews don't eat pork and they got it from the same God, right? Instead, what happened is Muhammad was like, "Hey, you Jews, God never made the pork as a wrong thing to eat. It was only what you guys did, right? So I blame in the Jews, right?" And then later on, Muhammad's like, "Oh yeah, God's told us not to eat pork." So effectively, he basically tries to. It's completely like yeah, you know, changed what the Jewish people were believing, and I think anyway, you can go and look into yourself. So I wouldn't necessarily call Islam Abrahamic, basically. You've also got stuff like anyway, do your own research. Plenty of more concise resources out there to look at. Right, so this code looks a little bit, I try and write code where it's like readable, right? I despise comments. Comments are usually the worst. So sometimes I'll probably try and put these stuff into functions so it just kind of reads better. But I'm wondering whether to drop a comment or change it to be functions, right? Because this just looks a bit crazy, right? But then if I put it into functions, you're basically chasing, right, around different functions to try and understand what goes on when this is the only place where it probably happens. But I think it's going to happen. It might happen in one more place as well, actually. But we'll see. I think this whole thing might be made into a function inside the loop. Oh, hey there, Hatatsu. I wasn't talkative? Okay. Yeah. Well, God has done a lot of work in me now, so I'm much more of a better person than I was in the past. And, I don't, yeah. That's why. These days, I'm able to talk in front of the crowds and things, and something I can never do. But, God has changed me, so I can do such things now. What we're going to do, commands to run. So yeah, if we decrement those, right? If they become 0, then these are commands to now run instead, right? Yeah, so that's kind of interesting, right? So if this is successful as well, we want to remove it from the array, right? So I think in this case, yeah, it's kind of a... Yeah, so this wants to append it on the back. This one... Yeah. So I think we probably want to do like a... Right, grab the one from the back, if there is one. So if index plus 1 is less than commands count. So if it's not at the back, right, let's grab the one at the back and store it at the current index, right? And then you want to decrement the index such that when the next for loop comes around, so it is going to underflow, that's fine. And then it'll overflow again when it comes back around and go back to 0. So yeah, that's removing this command because it's no longer needed to be ran and built. This one here is going to be like, well, if this is now equal to 0, then we now insert. So it's like this code up here, basically. We could probably make macros to make that a little bit more legible. That might be the way to go. I don't know. So, yeah, this code's looking a bit mad. Okay, so then what this is going to do then is add some more on, but then it's going to just even look at those ones as well, which is kind of cool. So it does it. Oh, except for this remove from back type thing is actually going to bring stuff at the back to the front, and then it does it kind of out of order, which then means it might create some problems. Right, because you could have some dependencies. Yeah. I think you want to do it in order, in this kind of order, I think. So, yeah, I think we want to build a bunch of indices. That we want to essentially not. No, you could just write nulls, right? Just literally write a null in there. That is probably the way. And then we can like condense it. No, we won't even condense it. Basically what we do is we, yeah, this is way better. Write a null in there, then basically go over the full thing at the end, and then simply like fire it off on the executor. So executor, so Q command, and you just Q C right there, but only if C is not null, yeah? Ta-da! Have you ever used a stack with two heads at opposite sides to share memory between two data sources that grow in a complementary fashion? Nice. Or tend to be complementary or exclusive statically, perhaps with a statically sized allocator or container? That's a good question. So I've never done it myself, but I've known of the trick. Now, the interesting thing is, it's interesting to bring that one up, because on my interview question for the job that I'm currently at, which I've been there for nearly 5 years now, I think. I forget specifically. Oh yeah, it's coming up to 5 years in the next month. So basically, one of the interview question was I forgot how it was phrased, but it was something along the lines of like, you only have one block of memory or something like this, and or um, yeah, there was a specific way the question was arranged such that the answer had to have been this one thing that you're proposing, and I managed to like work it out and guess that they were saying basically, right, you allocate the front and then allocate the back. Such that you have two independent arrays that you grow. You know what? Actually, I might have done this before. Maybe I've done it now. Yeah, it was like, how do you build two arrays from like one block of memory or something like that, such that you retain the order or whatever. And yeah, obviously it's like push front, push back type of thing. And apparently it was used in some game as some like, that's why they used it as an interview question, because they used it in the past to solve a very specific problem. It's a good idea. It's a great one to remember. But yeah, the only issue with it though is obviously you want to make sure you've got enough room. And say if it's just literally like, hey, I've got two different types of objects, but I know the overall count, and they sort of, as you say, it's like a complementary thing where it will be one or the other which gets used, then it will be fine. Right, it's cool. But yeah. Right, so I think this is the executor code, right? How do you basically queue it? Or maybe it's not really DAG execute, but it's maybe sort of DAG queue for execution. I think that's probably the better name. You can also cascade them, but one stack will be a master. Right. And the one in the middle will be completely unused. But your runtime checks sometimes to make sure the ones in the middle are unused. A bit like a union. Right, I think I get what you mean. Yeah, you can like cascade into it. Yeah. Nice. Right, so let's double check this logic and see if we can like clean this code out a bit. So right, so find all the source files that don't need generators in at all. Right, let's write the comment down for this one. So we want to say inspect each command and see if it doesn't need building. If so, decrement. Yeah, I think that can be made a function, right? If so, decrement the depending command nodes and queue up any new commands, any commands that reach 0 when on dependencies, right? Something like that, okay? So this guy here, right? So you're basically saying so we're going to need a function on the other in the executor, which basically says, right, this command finished. This command has finished. Decrement. It might be this, right? So you could probably have like a callback function that's kind of horrible. Because I think they're going to be going to different things, right? But you could equally just put them out into arrays, like a little local array or something. And then I could put that into a queue from there. That way the function could be reusable or whatever, but equally just copy paste the code, right? So it's only in 2 places. Yeah, I think this is fine. Right, so let's just double check the logic makes sense. So right, find all source files that don't need generated at all, right? We go over all the command nodes, just loop over all of them. Check the input dependencies. And see if the file nodes have no creation command. If so, insert that into the array. So go over all the commands that we now need to run. We go over all the inputs. If all of them don't need building, so I guess I can do this continue thing to avoid extra indentation. I quite like doing these. Then we then go over all the outputs. We check the dependencies of that file node. Or what else is in there? Yeah, not much. So the commands which are dependent on this file node. Yep, that's the way to go. So we keep looping over and decrement the counter, and the counter is 0. We could probably put an assert in here to check if it's not 0, but I think it should be fine. and we add it to the array. What command are we adding? I'm glad we checked this. We're adding the command in here, right? It was the wrong one. Then we just go to the next command dep. Right, the next file dep. Lovely. And then we mark it as null. The command here that we've looked at running, and it's it no longer needs building, basically. Cool, then we just basically launch all the ones we need building. Ta-da! Nice. That's really good. Right, so now that's done, let's look at some other ones. Let's look at maybe, so we could do the watcher here, the directory watcher. That might be a good one. Or we could look at the executor. So the executor is a separate thread which runs. And, you know, when it's doing nothing, it just waits, right? So it's not using CPU time. And when a new task comes on the queue, which we queued up by doing this execute queue command just a second ago, right, queues up a command for the executor, wakes it up. It goes and basically creates the process. Creates the process as a running handle, installs the running handle here. So you have as many running handles as there are threads on the system, right? Maybe we'll do threads take one, I don't know. Then we obviously wait for any of them to be completed. When any complete, we will basically handle it here. So this handling code needs to be done. What do you know about Ada Spark? Absolutely nothing. I know Ada is a programming language, but I think you're talking about something else, maybe like I know Spark as well as like a CPU architecture maybe, but maybe, so yeah, I don't know what you're talking about. I know it's something to do with computers, probably. Things that go beep beep. So the find dependency passes. So I don't think that really needs to do anything. So we can just skip that. This one does though. So that code that we literally just wrote. So queue for execution. This guy, we're literally just going to take all this code here and drop it here. So, a little bit off. It will be this code. Man, this will be so good when it's done. So dag file node fdep, yeah. So the task contains the command node. So that'll be task command node. Oh, it should be a file dependency, actually. Right, so here we go. So we've completed a command, we go over the dependencies, find any future commands which need running, and then we find out that there's one other one to run basically. So I think from here we can queue. Now I'm a bit skeptical about this, but we'll give it a go. So I think we can do a executor queue command. But I think I've built the sync code to only handle it from another thread, I think. Like a single producer, single consumer. But now you kind of got like multi-producer, right? Because the executor itself wants to put on to its own queue. But I think it's fine. Just got to double check. So what you would do is do a push. The push will atomically load the tail, check there's room, and then use that one. Right, so that's called from 2 threads. Should be fine, right? No, it shouldn't. Because later on, it's then going to do a commit, right? It's going to do an actual append, like one of these. So, like you can have the other thread could have been mid-flight trying to push another one. No, it might not, because the DAG only gets executed when the DAG. No, it's completely safe because no other thread is doing it at the same time. So I'm going to put a little thing in here to say completely safe. Or maybe I should put as the main thread will not be pushing, will be not be using this at the same time. It'll be waiting for the executor. Spark in this case is a subset of Ada, which uses SMT solvers and user annotations to prove the absence of runtime errors related to memory, data races, and arithmetic. Right. NVIDIA uses it for some drivers and car companies. Okay. It doesn't prove functional or logic correctness. This is not theorem proof. Right. Okay. Right. Nice. Fair play. Yeah, I guess where you need safety and stuff, maybe. But yeah, you know, more help the better, maybe. But it really just depends on the sort of like language constructs they build, right? Say if you build a more complicated and hard to use language, but it's safe and solves those problems, then it means you might actually create more errors in the places where it's not solving, right? So like for instance, just in the functional or logical correctness, right? So that's something to be aware of, right? Right. I'm glad we've done that. That's pretty cool. So the next thing to do is sort out the directory watcher. Right. So this is like the main loop, basically, right? So we reset the DAG. We build the DAG again from scratch. If we came across any dependency, yeah, you know what? I should just do this. This makes it complicated. This is way better. There we go. Easy. Right, so if it came across any like clang commands or shader compile commands where it's like, I don't have all my dependencies because I've not ran the build yet, and I don't have a dependencies file, right? So then it's going to basically launch on the executor a bunch of like dry runs or whatever, where it basically doesn't compile the code, but it asks the compilers to generate these .d files, right? So they get built. And we just wait for them, and then we continue, reset, build the DAG again. So this only happens when you add a new file or when you've never built the executable before or you've blown away your build directory, right? So, you know, we want to try and avoid stuff like this as much as possible, and thankfully we can. Right. And reusing the old .d file is enough, which is super cool. C doesn't help you, but that's why C developers learn a lot. Yeah, you know, there's a thing, right? It's like you don't want stuff to be hard for no reason. Because if it's hard for no reason, I then like it's just a pride thing, right? Um, or it's just an impractical tool, right? Um, but yeah, if something is hard, you also don't want it to be hard to the point where it's not giving you any benefit, right? As I just explained earlier, right? If you have all these safety tools but they don't really yield, they create more problems than it's worth, then it's not worth it, right? So yeah, with C it doesn't help, but C does help you in lots of ways, is because what C is it's simple, right? C doesn't have lots of constructs. So when you're looking like a C++ code base, especially a big one, guaranteed someone has used every feature. So then you have to know every feature of that language, kind of. And stuff magically happens as well. Like it's kind of crazy that you have like destructors going on, you have like constructors going on, like implicitly. So, and then like move constructors and copy constructors and all this stuff just makes the code base really like you got to have a lot of knowledge, and it's just for me that's just a level of like impractical amount of difficult. It's more impractical than it's worth, all those features. So with C, the benefit is that it doesn't really have a lot. So now now you're mostly concerned with the operating system, how that works, and the hardware, how that works, and your system, how it works. Yeah, C stands for simple, exactly, with a capital C. I was thinking that when I said it as well, which is kind of funny that it kind of made you think the same thing. It's kind of cool. Um, yeah, it's a bit like with all this AI stuff, right? I don't usually like talking about AI, but I guess I want to bring it up because I was talking about it today with someone. You know, sure, there's some benefits that it can bring, right? It can write code like stupidly quick, but like, is that the code that you really wanted? And are you leaning on it so much that you're now just becoming a worse developer? So like, you've really got to weigh all these things up and make sure they really pay off. There's pharmacy you can use, right? Sounds like pharmacy. Um, but you can use like some nucleus facilities and rockets use it. Okay. You write your assumptions before your functions. I've never seen that pharmacy thing. Huh. This might not be it. Anyway. But yeah, I know there's stuff like there's some other C safety. Um, there's a couple of C compilers out there which do safety stuff, but I don't think it's called pharmacy though. Yeah, you don't like hidden. Oh, I don't like hidden RAI and destructor inheritance. Logic becomes implicit, cannot read exactly. I like to write down my implementation in English in detail sometimes, and then AI can write code for me. It's that's convenience for those kind of transformations. Um, I don't know. Like, yeah, but I don't like the code that AI writes. I guess you can maybe make it try and match your code base, but still, you'd have. I feel like you'd have to massage it, or get it to massage it some more, a few more prompts, and then come back and tidy it up because it still didn't do the thing you wanted. And then meanwhile, you've just typed out you might as well just typed out the code, you know. Right, so reset DAG, build DAG. If we're doing any find dependencies, yeah, just wait for them to be done, then continue build DAG again, right? You should never get in an infinite loop there, right? Because the find dependencies don't have dependencies themselves. Then, DAG dump, right? We just want to dump it to disk so we can view it in graph.viz dots format. We can probably remove that, but for now it's useful. Then we queue the DAG for execution. So we've written out that code, seems all right. Then we wait for the executor to be complete. So that's just going to keep, the whole system basically, or this whole, for the most part, the build system is now asleep, and the executor only wakes up when the operating system's like, hey, your process finished, and then it sort of just goes through the graph. And it's like, all right, this one's next, puts it on the queue. And puts it on the queue, and then yeah, it goes and grabs another job and launches it. That's kind of interesting, right? Why does it bother putting it on a queue? Oh yeah, because there might be too many things for you to then. Yeah, we'll put it on the queue and then we'll go around and launch it. We could try and launch it right away, but it's fine. And then we wait, and then after that, right? So I guess now we want to ask that question: what happens if stuff fails? Because we're not done that yet, right? So we've got a whole tree of things which are executing. Do we try and run absolutely everything that we can? And then I think that's probably wise, right? You might as well. Or should you? Because if maybe you should just stop, right? It's like, well, an error happened. Let's just stop and then show the error. Yeah, I think that might be better because you can have such a big pile of things, and then you got to find the error and error, and you have to rerun the whole thing again. Yeah, and then say if you basically here's the other thing. You might launch a build and say if it had to wait to build everything, but it's errored on one file or whatever. You might have to go in and change some files and then just rebuild all that stuff you've just built anyway and never used. So yeah, I think what we want to do is like if we encounter some kind of error, where's the executor? Yeah, yeah it's hot. All right, yeah. Call him. You have to tell it change it a handful of times for the situation. Happens to have English version nearby. Right. Yeah, I do sort of agree in some regards. Like it's nice having, what helps me understand my code more when I start like explaining it. Maybe write out a comment, and then it's like I'm like logically thinking it and processing it and be like, oh yeah, that's wrong in the code. So it's good to kind of do that. But usually what I do is just delete comments anyway after I've written them. I like a code base with like basically no comments if possible. But yeah, I do see the handiness of having stuff written down in English in a way. Because there's something about code where if your code is not readable and you have to put comments down most of the time, typically I think you're doing something kind of wrong. Like code should just be legible. Oh, these are my favorite ones. I come across these all the time. I watch this. This is like the fruit of many code bases. Ready? dump the DAG. Q DAG for execution. Wait for executor commands. Executor finish executing commands. Right, that'll be helpful. I'm glad I've written comments now. You know, like, yeah. You know, the function should just explain what it needs to be and just, yeah. The code should be readable, not the comments, right? But yeah. I see it so many times, it's really bad. So bad. And part of the reason why I think AI does that is because people write comments like that all the time in their code. Right, where are we going? So yeah, well, what's this one to do with executor, right? The executor. Oh yeah. What happens when we got errors? Errors. So where's the error happens? So when the executor execode log error execode this guy. So we want to go into some kind of mode now where it's like, yes, I think we say executor bool is shutting down. Or stop found error. So we shall say am I using entity component system? I don't know. I'm not doing it yet. I've not written the game code yet. We're going to write the game code soon. I don't know if I'll use one. Maybe I'll do a little... I don't know yet. Maybe. The comment should contain things if you can't put in variable names. Yeah. Like design decisions. Yeah, exactly, yeah. Like auxiliary information. Not duplicate. Right, so say if we make this variable do that, then like the executor, like, so the running count is equal to 0. Wait, right, so running count is equal to 0. Then I think we want to say if it's not stopped. Hey Sully, how you doing, sir? Welcome, welcome. Are you thinking about your ECS? What you doing? So here we've found there's running. Right, so basically don't launch anymore. Wait. Right, that's the idea. Don't launch anymore. Wait. Now, another thing is like if we're stopping, or maybe we phrase it a bit differently. I don't know if we wanna. Yeah, we'll keep it. Yeah. So, and also like, literally, if we're here, we don't need to process any of this stuff, right? So if we've not stopped and found an error, you know, go ahead and queue up the next thing. Whereas there's no point running that code. There we go. Cool. So this is nice, and we want to clear it when the waits complete has successfully returned. I think you want to do that, right? So yeah, you want to clear it after this function returns. Nice. Yes, that's how we handle errors. They'll be printed out to the terminal, and then it'll do a directory watcher events wait. And then we process the events, right? So how do we handle this? So we've got a new event. Now that I'm not handling all the events. I'm only handling like if a file's been modified. But now we'll go back to the watcher. There's actually, we want to make it handle a few things, right? So file notified changed last write. And I think we want a creation one because then we can handle new files that have been added to, like imagine just adding a new GLSL file, you can, or something like that. No, we'll just compile it. Maybe. But equally, it might just show up on a last write anyway, because the fact when you create, it has to write. So maybe this is fine. All right, I think we'll do that. We'll see. Right, so let's just take it in and we just say, right, okay, so file database. Did you do update or something like that? Update e path. Now I'm pretty sure I normalized it. Yeah, I normalized it. Cool, that's exactly what we want. Nice. Maybe it's better to just make it a string because then it's doing a string length while the memory's in cache. I think that would be better. String C. Oh, we already have a path size right here. Even better. Man, that'd be cool. Right, so going back to where we were, we'll literally just do an update. What does update do? So it does a find on the metadata. If we find it and it needs a build where it's already been updated, don't bother updating it again. Right? If not, get a stat and do this update with thing. Yeah, I don't think we need update with. So update with used to like... Yeah, this thing was architected in a slightly different way. Where we would... Yeah, the timestamp system was sort of built into the watcher. It was a bit weird. Yeah, I think we can just get rid of... Oh no, but... Yeah, we'll I think we'll do this. We'll see. Get rid of some extra functions. Maybe we could just call it time. It'd be a little bit less error prone. Right, I like that. That's good. So that's just going to do the timestamp. So now when we rerun the graph, it's going to do that needs build, and then you'll just have a new latest. Right, so that was the other thing that was missing. Is like, right, this is a successful build from here, maybe. Right, so we kind of want to know, was it successful? And if it is successful, right, so if there was some error, Yeah, so it would be kind of nice if even if there was an error, all of the successful builds, those you sort of mark and say, right, these files have been have built the latest set of work, something like that, with these timestamps. Yeah. So we need to somehow like walk the DAG or something like that and check like was that command executed successfully. Maybe we'll just have an array or a bit set, something like that. We'll see. So have you used runtime function constant specialization? Ooh, like constant folding and doing strength reduction to generate simpler code. That is optimized for a particular machine or game condition. This is JIT stuff. Sometimes you need despecialize to something like in Java. No, I've not really done anything like that. Like I know what that stuff is and implemented. Like I wrote my own compiler and stuff, so I implemented some constant folding stuff and I understand how like um optimizers work and compilers and stuff, but no, I've not done any of that. Are you talking about like how sometimes people would do self-modifying code, right? And in like old games with assembly, wouldn't they, right? Is that a similar thing to what you're talking about? Yeah, no, not anything like that. Sounds cool, but no, I haven't. Right, so the executor is gonna be like, this command finished successfully. And so all of those input files, so say you've got some header files, right? Say if you've got, I don't know, core.h. Core.h is used by absolutely everything. So we kind of want to say, so when core.h changed, it's saying all of those C source files need rebuilding, but you started rebuilding them, built quite a few, but not all of them. And that's interesting, isn't it? You built quite a few, not all of them. Oh yeah, we should write this down because it'd be better if you guys can sort of see what's going on in my brain. Right, here we go. So we've got like core.h. Say if game.c uses it, you've got gpu.c, you've got graphics.c, right? These things use it, right? Game.c builds, gpu.c builds, but graphics doesn't. Right, the way the system currently works is then it says, right, core.h, right? It's got a thing to say like whether there was a successful build with core.h. And because graphics.c failed, now core.h doesn't really get marked off to say, hey, it was successfully built with this core.h at this timestamp. So now it has to rebuild game.c and gpu.c when we make a change to the file system next time around, right? And re-trigger a build, which kind of sucks. But it is ran on loads of threads, so maybe it's fine. But it's an interesting problem, right? So it's like you're basically maybe instead of what you need is like this command with these inputs successfully compiled with game.h, this new game.h. Whereas this graphics.c did not. right? So we could change the file database to instead be sort of like more of a tree. Interesting. Hey there, France. I'll just call you France. Hey, sir. How you doing? What is this? We're making a build system in C, and I'm trying to. Effectively, the idea is it's just going to be watching for the file system for some changes. It's out running a separate program. You don't have to go and say, "Hey, run a build," and it's going to build all your files across as many cores as you got available. And when it's done, it will tell the game and say, "Hey, I've built this thing and all these assets. You should probably reload those." And the game's like, "Sure, I'll reload them." So this is basically the system. Um, you know, um, it's just nice to have a um, yeah. This is just something I've sort of envisioned because currently my workflow is sort of like switching and running a command type thing, and it adds time. And also, the code base as well is available for people who support the stream, and they might not use my editor, and they might want to use Visual Studio or some other thing. So having the build system sort of not integrated into these IDEs, which sometimes things like to go, it's just a separate thing which runs on the side and does its job basically, and it automatically does the hot code reload and stuff by the game not having to watch the directories. It will just get the information from the build system. So this is what we're working on basically. It's for the game engine and the upcoming game that we're going to be building very soon. But yeah, if you got any more specific questions, I can also answer those. But that's the best I could derive from your question. But yeah, so we got a thing, right? How will we do this? Do we go to some kind of like tree-like solution with the timestamps to handle these problems? Because it could be quite annoying sometimes, maybe if the code base is big enough. I don't know. We should have a think about it. I'm just gonna get another drink and let my brain take a few minute rest, and then we'll think about this problem. But yes, it's good progress today. I like it. BB. Right, welcome back. So we're trying to solve that problem where it's like build system has now ended because of maybe an error or not really an error as well, but we're going to try and sort of mark the file database and say these files have been successfully built. Sorry, wrong way around. These input files that we used made successful builds, such that when we try and build the next time around, we can look at the timestamp and be like, yeah, so yeah, we look at the timestamp and be like, oh, we don't have to build this command because we've already built it, right? All the inputs, those were the last ones we used. So that's what we're trying to investigate. Let's imagine you had to start computing from scratch. You only had a hex memory editor, and only write machine code in hex into memory. What would you make first if making a mistake? Oh no, this sounds crazy. What would you make first if making a mistake that crashes the computer kills you? Huh? So the first thing I would do is make sure I've accepted Jesus Christ, because these are very high stakes, and you need to make sure I'll make sure read the Bible back to front, understand that I'm saved by grace through faith and not of works, receive salvation and the gift of the Holy Spirit in full by believing in Jesus' finishing work on the cross, that by his blood my sins have been paid for in full. And then I don't know if I'll touch the machine. Do you have to play this? Yeah, why would you try and make Pong if the computer is going to kill you? Like, it's quite insane. That's too risky. Like, my addiction is not that much of an addiction. Like, basically, I'll dismantle the computer and then find the thing which tries to kill me, right? And if that's impossible, we'll just buy another computer. Yeah, that sounds an extremely unrealistic place to be in, unless maybe you're on board some kind of ship and the AI is trying to kill you, and all you have left is an old computer and a hex editor, and you got to somehow make a virus which destroys the evil AI. I don't know. And then if you get something wrong, the AI discovers you and hunts you down. Maybe that's more realistic. I don't know. Maybe not. If you're in an escape room, you need to call an API to open the door, and you die if you stay in the room too long. Right. I don't know. Yeah, I have no idea. Sounds like pain, honestly, trying to write an hex. Man, trying to remember the Intel instruction set and how the exact bit pattern of all of that, that'd be a nightmare. Oh, I made the compiler for SPIRV. Yeah, I made one for that. For C, basically, to compile C to GPU. That's what I made. In the past. I put the project on hold though because it had there was SPIRV kept adding new rules and stuff, and my compiler started getting a little bit too much tech debt, so I just a bit too much of a bugger to maintain in the end. Right, so yeah, what two approaches we can take? We can either have a global file database, which we have right now, where you just have a file and its latest successful build it was made against, right? But then you have that, this is the problem you have, right? You could say core.h, right? It could build either, it builds game.c depends on it, gpu.c and graphics.c. But then game.c and gpu.c successfully build, then graphics.c doesn't. Right, and this could be even do with assets as well, right? So then maybe assets will have a similar thing. Maybe they won't. It's probably most likely just going to happen with C files. Maybe. So then because core.h didn't finish all of its dependencies. Have I got my depender and dependency thing the wrong way around? I think I have. Yeah. So all things which are dependent on it. So the dependers. Yeah, I've got. Yes, all of its dependers. I've got those the wrong way around in the code base. I'll sort that out. Yeah. So all of its dependers did not build successfully. So in the database, we cannot save a sort of successful timestamp for this file. So that means when we next make a change, these will have to be built again. So the other approach you could take is a command. The command we could somehow, well, it's quite easy, right? You hash up the command, but then you just want to make sure you don't, so just the command string, right? That should be deterministic. So you hash up that command, and then that command has a list of files. So it will have core.h in there. And so that means inside that sort of file database, we'll parse that up, and then it will store the latest timestamps that command has been successfully built. So the latest files, the timestamps for the files it was dependent on when it last successfully built. Yeah, I think that's what you want. It's not too much more work either. And it's a more correct thing. Because then, but it is going to be a little bit more. Yeah, I think that is better. Personally, I write exception handlers and call my memcpy implementation to restore previous memory state. Then I'll try to clean. So try some code and save it first, right? Yeah, exactly. That's the thing, is you can crash a crash handler or whatever, yeah. Yep. Very true. Right, so I think that's the solution we'll go for. I've got to change that file database thing that we slightly refactored today, but it will really solve that problem. And I don't even think like Ninja does it that way as well. I think Ninja does it with just a file, right? Maybe it does it a little bit more complicated, but I don't know exactly how it works. But yeah, this solution will be great. So I'll slap it in here. To do change file db to track timestamps per file timestamps per command rather than globally. Okay. So the thing I wanted to sort out is I've got this word like dependencies and dependers, right? A dependency is something you're waiting on, right? But I think I did it the wrong way. I think the wrong way around. Like this isn't. Right, if you add in an input, So we add an input to a command, and we now make a new dep. Yeah, this file, it says dependencies. These are, it's dependers, right? So right, waiting on dependers, waiting on the dependencies. Oh, right, see you later, Ben Chillum. Actually, yeah, good to see you. Have a good night. Right, that's a good one. Change that again, dependers. Alright, I'm glad I remembered that. Okay, so let's see what we can think about that change. Right, I think we'll do that some other time actually. Right, so in the meantime, guys, there's a Discord if you want to come and chat off stream about programming or even the Bible as well. We talk about the Bible there sometimes too. And if you want to support the stream and get access to the codes to run on your own local machine that runs on Windows, all the information is on that link. Or if you feel like you just want to support the studio and the efforts that we're going to be doing, yeah, please consider sign up for one of the yeah, please consider sign up for one of the memberships there. But yeah, the next stream, Tuesday, 7:30 p.m. GMT +1, so it's in the next couple of days. The same time again on Thursday and Sunday next week. There's also a Friday stream at 2 p.m. GMT +1. I think the schedule's all down below in the Twitch channel, Twitch chat. Sorry, Twitch channel thing at the bottom. But anyway, yeah, that's about it. But yeah, have a good night, guys. Have a good bank holiday if you're in the UK. And I'll hopefully see you all in a future stream. Very much love, guys. Good night.